Today we'll be looking at the first segment of this part. We'll be looking at writing word equations and symbol equations. So how to write word equation. First of all, in chemistry, we characterize reactions with equations. We characterize chemical reactions with equation. Meaning, whenever reaction takes place, we can show it by writing an equation on what has taken place. Okay, so word equation is used to show the reactant and the product. You know, in chemistry, the reactant is there and the product is there. The reactants are like the ingredient that react together to form the product. For example, if you want to make a soup, you need the seasoning cube, you need salt, you need pepper, you need chili, you need tomatoes, so all these are like the reactant. When you blend them together, you're going to make a soup. The soup is the product, which is chemically different from each of the product or each of the reactants that form the product, right? Which is the soup, the product, the soup, the reactant, all the ingredients like the pepper, the chili, the salt, the whatever, the tomatoes, the seasoning cube, the whatever you put, the fish, the chicken, everything, each of all of this, they are the reactants. Then they blend together, you make a soup, and you get the product as the soup. So the product is a chemical reaction. Why? The product is as a result of chemical reaction because the properties of the product, the soup, is different from each of the individual reactants that forms it. Okay, so that's just to give it a clue on what this is. So reactants are substances that are usually put on the left side of an equation, while the products are put on the right side after the arrow. Okay, put on the right side after the arrow. So let's move on quickly. So let's take a look at a reaction, a chemical reaction. Okay, when sodium hydroxide, which is a base is an insoluble substance. When a base reacts with hydrochloric acid or any acid, which is when they react together, they're going to produce a salt and water. They're going to produce salt and water. So when a base reacts with acid, they produce salt and water. Now the base, the alkali, and the hydrochloric acid, these two things will bring the reactant. Okay, they are on the left side of the equation. So a good example of this base is sodium hydroxide. This sodium hydroxide reacts with hydrochloric acid to form sodium chloride and water. Remember, this is a word equation. First of all, we're looking at word equation. We'll look at the symbol equation. We'll begin to write symbol thereafter for sodium hydroxide plus hydrochloric acid, and we get sodium chloride and water. Now let's take a look at more examples. For example, ammonia can react with what? Nitric acid. So if we take ammonia to react with nitric acid, we're going to get ammonium nitrate, something like that. We're going to get ammonium nitrate, okay, which is a fertilizer. Ammonium nitrate is a fertilizer. So ammonia reacts with nitric acid, we form ammonium nitrate. Okay, now let's take a look at another one. We say iron 2 hydroxide and sodium sulfate. Iron 2 hydroxide and sodium sulfate. Iron 2 hydroxide and sodium sulfate, when they are products that can be formed from iron 2 sulfate reacting with sodium hydroxide. Okay, we're going to take a look at that. This second one, we're going to take a look at that. So iron 2 sulfate react with sodium hydroxide, you get, because this iron will be displaced by sodium. Sodium is higher in reactivity series than iron. So sodium will display iron, it becomes sodium sulfate. Okay, and iron 2 hydroxide, and that's what we will produce. Okay, that's that for that. Then another scenario we can have is when carbon reacts with oxygen. You burn carbon in oxygen air, you get carbon dioxide. Okay, so these are symbol equations. These are word equations. We give you about 4 word equations. We gave one here, the very first one. Then we gave additional 3 word equations. Carbon is the main element found in the coal and it burns in air to produce carbon dioxide. Carbon burns in air to produce what? Carbon dioxide. When you burn carbon in air, you get carbon dioxide. So this is a word equation, and we've written it out here nicely. We've written it out here. Carbon reacts with oxygen to form carbon dioxide. Carbon reacts with oxygen to form what? Carbon dioxide. Okay, now we move on to symbol equation. For symbol equation, we need to know the symbols of every element. We need to know the symbols, how to write the chemical symbol of element. For example, hydrogen is diatomic, so hydrogen is H2. Nitrogen is also diatomic, nitrogen is N2. Oxygen is also diatomic, oxygen is O2. We talked about in part 1. We talked about the 7 diatomic elements in the periodic table. Then the halogens, the rest are the halogens. The other 4 are the halogens: the fluorine, the chlorine, the bromine, and the iodine. So that's why you see they carry 2. Okay, they are diatomic elements or diatomic atoms in the periodic table. Now, these are the symbols we use when you write the equation. You use the symbol of every element, and then remember to put the state symbol when we write symbol equation. Solid, we use small s in bracket. Liquid, we use small l in bracket. And gas, we use small g in bracket. And aqueous solution, we use aq in bracket. Now, let's take a look at an example. Let's write one example. For example, a symbol equation must be balanced to give the correct ratios of the reactants and product. We must balance the equation, okay, to give the correct ratios of reactants and product. Now, let's take a look at what we have here. You say sodium, okay, you say sodium react with sulfur, not sodium. Sulfur react with burning oxygen to get sulfur dioxide. Okay, sulfur burning oxygen to get sulfur dioxide. Sulfur is a solid, oxygen is a gas, and sulfur dioxide is a gas. So what we do is the solid, you put S in front of it, gas, you put G in front of it. These are called the state symbol. So every chemical equation you write, reactions you write, you must put their state symbol. Because sulfur is solid, you put S. Oxygen is a gas, you put bracket G. This state symbol that we discussed here, you must include them when you write the equation. When you write the equation, is that okay? You include them. So sulfur plus oxygen, which is a gas, forms sulfur dioxide. Now you can see it's balanced. How do you balance the chemical equation? You can see one on the left, the reactant side, there's only one atom of sulfur. On the right, there's also one atom of sulfur, which is the product side. So sulfur is balanced. You look at oxygen. How many atoms of oxygen are on the reactant side? 2 atoms of oxygen. How many atoms of oxygen are on the product side? 2 atoms of oxygen. So it's balanced. So when we say balance in chemical equation is to check the number of atoms on the reactant side and the number of atoms of the product side. If they are equal, if they are same, then the equation is balanced for every element, for every of the atoms or elements. Is that okay? Now we move on to balancing symbol equation. Now we want to balance a symbol equation. Every symbol equation you write, you have to balance it like we said earlier on. This is sodium hydroxide. Sodium hydroxide is an aqueous solution because it's soluble in water. Reacting with hydrochloric acid, which is also aqueous. Acid and alkali, they are aqueous to form salt, sodium chloride, which is also aqueous because it's soluble in water, plus water itself. Water is liquid. Okay, so now how did this equation or this reaction takes place? First we take a look at the equation itself. Take a look at the equation itself. Now you can see one atom of sodium, one atom of oxygen here, one atom of hydrogen form this sodium hydroxide. Then here you have one atom of hydrogen, one atom of chlorine, which is hydrochloric acid. This is an acid. We're going to do this chapter acid, bases, and salt very soon. So when you react with acid, you get sodium chloride. Why is this sodium chloride? This sodium is higher than hydrogen in reactivity series. You know, if you are higher, you can displace the one that is below you in reactivity series. Sodium is higher than hydrogen in reactivity series. So sodium has the ability to tell hydrogen to stand up. Sodium will replace this hydrogen. So it becomes instead of hydrogen and chlorine, it becomes sodium and chlorine. It becomes sodium chloride. That's how we got this one. And this is called the salt. This is salt. Sodium chloride. This is the common table salt that we use in our home. Sodium chloride. Okay, so sodium is higher than hydrogen in reactivity series. Sodium will displace hydrogen and it becomes sodium chloride, aqueous. And then the hydrogen that is displaced here combines with the OH here. Combines with the OH. Sodium has left this position. Sodium has left here and came here to displace hydrogen. So the hydrogen that is displaced will come and join this OH. We come and join this OH to form H2O. To form H. There are two hydrogen now. One hydrogen here and this hydrogen. From H2O. Okay, if you look at it, it's balanced. One atom of sodium on the reactor side, one atom of sodium on the product side. Two atoms of hydrogen, one here on the reactor side. Two atoms of hydrogen on the product side. One atom of oxygen here on the reactor side, one atom of oxygen on the product side. So when you look at it like this, you see that everything is balanced for this equation. So this reaction is called neutralization reaction, okay, of acid and alkali. Acid and base or acid and alkali. Base and alkali is interchangeably used, okay. An alkali is just a soluble base. An alkali is a soluble base. So they can be used interchangeably. Remember, an alkali or a base is a protoacceptor, while an acid is a protodonor, okay. This one is a protodonor. It has hydrogen ion in aqueous solution. Acid is a protodonor. It has an hydrogen ion in aqueous solution and is the only positive ion in this aqueous solution for this acid. So it's able to give it out. It donates it. That's why it's called protodonor. And proto means hydrogen plus. In this regard, proto means hydrogen plus. Okay, this is what we call the proton. So when we say an acid is a protodonor because it has it to give. And an alkali, we accept a proton from acid. So it's called protoacceptor. Okay, now let's take a look at a redox reaction. What do we mean by redox reaction? It means reduction and oxidation reaction taking place at the same time. One is B reduced, one is B oxidized. Of course, iron 3 oxide, this one is going to be reduced to iron. Okay, iron 3 oxide, this one is the reduction reaction because B reduced to iron. While carbon is oxidized to carbon dioxide. Carbon is oxidized to carbon dioxide. Carbon is oxidized. So this is a redox reaction. Oxidation and reduction is taking place in this reaction at the same time. Okay, so you can see here we go to balance. Okay, we go to balance. Iron 2, these numbers at the back are the molecules. They were included in the balancing. They were included, okay? They were added during the balancing stage. They were added during the balancing stage. Is that okay? Every number behind, like this 4, like this 3, like this 2, like also this 3, they were included during the balancing stage. Okay? Because ordinarily, before balancing, you would have had iron 3 oxide react with carbon. Ordinarily, before the balancing, it would have looked like this. Okay, you put the state symbols. Okay, we put the state symbol. Carbon is solid, iron 3 oxide is aqueous. Each one you put the state. If you want to get your marks complete in chemistry, you must put the state symbols. So become or produces iron. So iron 3 oxide is reduced to iron, which is solid, plus carbon dioxide, CO2, carbon dioxide, which is gas. Carbon dioxide is a gas. Okay, now this is the equation, the normal equation. Then you balance it. Then we balance the equation. So how we balance it? We look how many atoms of oxygen are on the left. Okay, we start with iron. How many atoms of iron are on the left? 2 atoms. Here is only 1. So if we put 2 here and pick 4 here, but if I put 2 here, my oxygen will now be 6. 2 times. This 2 is talking to both iron and oxygen. So 2 times 3 is 6. Oxygen is 6. So here, oxygen I have only 2. So I can put 3 here. Okay, put 3 here. My oxygen is 6 now, my oxygen is 6 here. Carbon is 3, so I can put 3 here to balance the carbon. Carbon is now 3 here because we put 3 here. This 3 is talking to carbon and oxygen. So carbon is 3 here, so I put 3 here to balance my carbon. So iron is now 2 times 2, which is 4, so I put 4 here. This is how we balance chemical equation, okay? This is how we balance chemical equation. That's it, and that's what they did here. That's what they did. So if you're able to write it, balance it, and put the state symbol, you get your 3 marks. Usually it carries 3 marks. Okay, now let's move on since we've seen an example of how to balance a chemical equation. Now let's see more example. Okay, when sodium oxide, which is a base, sorry, I said sodium, magnesium oxide. Okay, before we continue, let's take a look at a tutorial before we continue. Okay. Okay, so let's take a look at this tutorial quickly.
In this video, we'll be looking at how to write word and symbol equations. A word equation shows how chemicals react together in a reaction, changing from reactants to products. They are a simpler way to show the reaction compared to a written description of it. This is a relatively standard way to describe the combustion of ethanol, with extra information that is not relevant to writing a word equation. When you are given a description like this, you should be looking out for common words or phrases. For example, burns, which suggests a reaction with.
Oxygen.
To form, which indicates the reaction taking place as well as the reactants and products. In this case, the word and suggests more than one product is being formed. From the information, we get the following word equation. The word burns is represented by the plus sign. To form is shown by the arrow. And for carbon dioxide and water, the word and is represented by the second plus sign. Here are some more words or phrases that can be used in written descriptions of a chemical reaction. Using all of the information available, you should be able to write a word equation for any question. For some equations, you may need to deduce the name of one or more of the products. There are some general rules for compounds that contain 2 or 3 elements. We will use CaBr2 and CaBrO3 twice as our examples. CaBr2 contains calcium and bromine, while CaBrO3 twice contains calcium, bromine and oxygen. When naming compounds, the metal typically comes first in the name. This means that both chemical names start with calcium. CaBr2 contains 2 elements, which means that the non-metal bromine is the second name or surname. The element bromine changes to bromide to show that it is chemically bonded in a compound. This means that CaBr2 is calcium bromide. CaBrO3 twice contains 3 elements, which means that the non-metal bromine is the second name or surname of the compound. But the oxygen needs to be considered. So, the element bromine changes to bromate to show that it is chemically bonded in a compound that includes oxygen. This means that CaBrO3 twice is calcium bromate. It can help to read the name out loud as it should flow. For example, brominide does not flow naturally, but bromide does. The key information from question 1 is that carbon reacts with oxygen to form carbon monoxide. Since the question already has the reactants written in, you need to add carbon monoxide as the product for 1 mark. In question 2, the formula of limestone is CaCO3, which means there is calcium bonded to carbon and oxygen, and the ate ending should be applied. This gives the chemical name calcium carbonate. This means that the key information from question 2 is that calcium carbonate is converted into calcium oxide and carbon dioxide. So the reactant in this equation is calcium carbonate for 1 mark. The question tells you that the 2 products are calcium oxide and carbon dioxide. Both products are required for the 2nd mark. Question 2 is a good example of how marks can be split in 2-mark word equation questions. Remember, word equation questions typically contain all the information that you require, so take the time to read them carefully. Like word equations, chemical symbol equations show how a chemical reaction happens. For example, the reaction of sodium with bromine forms the salt NaBr. Remember, NaBr is a compound containing two elements, which means that the bromine becomes bromide, so NaBr is sodium bromide. Therefore, the word equation is sodium plus bromine arrow sodium bromide. Replacing the words with the chemical formulae gives you the unbalanced equation Na plus Br2 arrow NaBr. Chemical symbol equations should have the same number of each atom on either side of the equation. A common mistake when balancing equations, like this one, is to put a small 2 on the NaBr, but this changes the chemical and is incorrect. You can only put big numbers in front of the chemicals to change the number of molecules. So, to correctly balance the equation, you should consider the amount of each chemical. It can help to draw out the chemicals. We have one sodium atom and one bromine molecule, forming one sodium bromide molecule. To balance the bromine atoms, we need a second sodium bromide product. This means that the sodium atoms are now unbalanced, as there are two sodiums on the right-hand side. So, we need a second sodium atom on the left-hand side. Overall, we have a balanced chemical symbol equation with two atoms of sodium reacting with one bromine molecule to form two sodium bromide molecules. Drawing out the molecules helps visualise the balancing process. The key information in Part A is NH3 is made by the reaction of N2 with H2. Be careful, as the information is written backwards with the product showing first. This means that the unbalanced equation is N2 plus H2 forming NH3 for 1 mark. The second mark is for balancing the equation. The unbalanced equation shows that one nitrogen molecule reacts with one hydrogen molecule to form one ammonia molecule. To balance the nitrogen atoms on the left-hand side, we must make two ammonia molecules. This means that we now have 6 hydrogen atoms on the right-hand side, which can be made using 3 hydrogen molecules. Overall, we have one nitrogen molecule reacting with 3 hydrogen molecules to form 2 ammonia molecules. Correct balancing gains the second mark. In Part B, the symbol with 2 arrows pointing forwards and backwards shows that the reaction is reversible. This gains 1 mark. In Part C, the key information is that NH3 reacts with HNO3 to form NH4NO3. This gives the equation NH3 plus HNO3 arrow NH4NO3. Looking at the question, we can see that the equation is for 1 mark. The equation is actually balanced and therefore gains the mark. In any question, it is always worth writing the unbalanced chemical equation because you may still gain 1 mark. Word and chemical equations show how a reaction happens and are shown as reactants forming products. The information required to write a word equation is given in the question. Look out for some of the common phrases like reacts with and is made from, amongst others. Symbol equations are balanced to follow the law of conservation of mass, which means that they show how many molecules of reactants are used to form a number of molecules of products. Don't forget to check out all our other fantastic revision resources here at Save.
Okay, so we've seen it. Now let's go back to that we said when you react equations together. Well, let's say sodium and bromine. When sodium reacts with bromine, you get the product you get. When sodium reacts with bromine, you get sodium bromide. You don't say sodium bromine. The product don't become sodium bromine, okay? The product becomes sodium bromide if you react sodium with bromine. Remember, bromine is diatomic, so I'm going to write Br. The first 4 halogens, they are all diatomic. I'm going to write Br2 for bromine. Is that okay? I'm going to write Br2 for bromine. So when this happens, you get sodium bromide. So if you're asked to name the product, it's not, you don't say sodium bromine. Okay? You don't say sodium bromine. Now here, I only have NaBr. There's no 2 here. Why? Because the ion of this one, bromine, has only 1, -1. and sodium has positive 1. If you cross them, it's 1 1. When you cross them, not because of these two. We're talking about the ion. The ion of this one is negative 1, right? Bromine. Because it is looking for 1 electrons to complete its outmost shell, so the ion for bromine is negative 1, and the ion for sodium is a positive 1, right? Positive 1. So if you ignore the sign, if you cross multiply, it's going to be NaBr. Each of them is 1 1. Now, because this one, we need to balance it. Bromine has 2 atoms, so here is only 1 atom. I have to put 2 here to make bromine 2 atoms. These 2 molecules is number of molecules. These 2 times 1 atom, it becomes 2 atoms for bromine. And then it also makes sodium to be 2 atoms. So this sodium is now 2 atoms. You must come here and do the same to sodium and put 2 here. Now the name of this will be sodium bromide, meaning ending with IDE. So when a metal reacts with a halogen, it will end with IDE, sodium bromide. So it will be bromide, not bromine. The name will no longer be sodium bromine, but sodium. The name of metals, anytime you write chemical reaction, the names of the metal comes first. Okay, the metals come first. You don't say bromine, sodium. You don't say that. Sodium bromide. So the name of the metal comes first, and then the halogen, instead of being bromide, become bromine, become bromide. End with IDS. Now, if we have, if you have like calcium carbonate, you see this 3, there's oxygen added to it. Okay, we have metal, we have a non-metal, and then we have oxygen, for example. When you have 3 elements and there is oxygen among the 3 elements, the name will end with ATE. ATE. Okay? Metal and halogen will end with IDE. Metal and halogen, if you check our science in Wisdom Academy, I think we've treated this before. Science grade 8 or grade 9. We made one of the Wisdom Academy video. We're going to find this there. Okay? If there are 3 elements and there is oxygen, the name will end with ATE, meaning calcium carbonate. Nate. To end with nate, carbonate. You cannot say calcium carboxygen. No. The product, the name will be calcium carbonate. To end with ATE. Is that okay? So that's for chemical, so how we name them when they actually take place. Like this one, magnesium, there's 3 elements, magnesium, nitrogen, and oxygen. To be magnesium nitrate. To end with ATE, magnesium nitrate. Is that okay? So magnesium oxide react with nitric acid. We form magnesium is higher than hydrogen. We become magnesium nitrate. This magnesium will displace hydrogen. This magnesium will displace this hydrogen from this position because it's higher in reactivity series. So it becomes magnesium nitrate. Okay, because magnesium has 2 ions, it will cross over to. It will give 2 ions to this one. Nitrate has 1 ion. Nitrate has 1 ion. So magnesium will pass 2. When you cross multiply, the 2 ions from magnesium will come to the nitrate. The 1 ion from, nitrate has 1 minus 1. The 1 ion from nitrate will come to magnesium. That's why the chemical equation is like this. Okay, magnesium, if you want us to write it, you see magnesium, and then you write nitrate. You want to know how the formula will go. You want to know how the formula should be written, right? You write magnesium, you write nitrate. Magnesium has 2 plus. Okay, we did it in part 1. Magnesium has 2 plus, and nitrate has 1 minus. So I say you cross multiply. Use the crossover method, and you don't forget about the sign. You just cross. So this one becomes magnesium Mg. Mg1 is same as Mg. Mg1 is same as Mg. So you cross these 2 to this side, it becomes nitrate, NO3, multiply by these 2, so I have to open a bracket so I can write that 2. So I'm showing you how to write chemical equation, okay? You're wondering how we're able to know all these things, how we're able to write all this equation. It's very easy, okay? So you get this name, magnesium nitrate. Magnesium nitrate, why is it magnesium nitrate? Why is it not magnesium nitrogen oxygen? because when you have three elements combined to form, and there's oxygen among them, combined to form a metal and two non-metal with oxygen together with oxygen, the names end with ATE. The name has to end with ATE. If it's two elements with halogen, it will end with IDE, like sodium chloride. Sodium chloride, not sodium chlorine. It will end with sodium chloride, becomes sodium chloride. But this one, magnesium, nitrogen, and oxygen, becomes magnesium nitrate. Nitrate. To become nitrate. To become magnesium nitrate. Is that okay? So, magnesium nitrate is the salt. You know, this acid, this is a base. This is a base, this is an acid. They react together to form a salt and water. This is called neutralization reaction. To form salt and water. To form salt and water. Where's the water coming from? The water is coming, see the oxygen here, and this hydrogen that is displaced, they will come together to form water. They will come together to form water. I think this equation is already balanced. Okay, so now we see magnesium and nitric acid, you get, okay, same thing they are repeating here. So this is how we write chemical equations, and we move on to more equations, and we need to balance. Aluminium react with copper. Say aluminium react with copper 2 oxide to produce aluminium oxide and copper. Okay, copper 2 oxide has been reduced to copper, while aluminium has been oxidized to aluminium 3 oxide. Aluminium has been oxidized. We also go to do oxidation reduction reaction. Okay, aluminium has been oxidized to aluminium 3 oxide, while copper 2 oxide has been reduced to copper. So this reaction is a redox reaction. So in the exam, they might write equation like this for you. I ask you to state which type of reaction is taking place here. Redox reaction, redox. Okay. Now let's balance this equation. Aluminium reacts with this. Aluminium is higher than copper in the reactivity series. So aluminium will tell copper to stand up. So aluminium will sit with oxygen. So that's where you have this one. That's where you now have this aluminium oxide. For the number of atoms, we go to balance wherever we have. So aluminium oxide is solid. You should use the state symbol. Copper oxide there is solid. Aluminium is solid. And even copper itself is solid. All of them are solid for this reaction. So when aluminium displaces this copper, copper will not be on its own. Because copper does not have anyone to combine with. Aluminium will combine with the oxygen to form aluminium 3 oxide. Now, we balance the equation. To balance it, you look at how many aluminium atoms are on the right side and how many are on the left side. You can see on the right side we have 2. We have 2. So on the left side we have okay, but you have to look at oxygen. How many oxygen atoms are here? 3. We cannot have 3. So let's put 2 here. So oxygen can be 6. Oxygen can be 6. If we put 2 here, oxygen is now 6. 6 atoms of oxygen on the right. So we find how to make oxygen 6 here. So we can simply put, since there's no any other number for oxygen here, we can put 6 here. We can put 6 here. So oxygen is now 6. Copper is also 6. So we can put 6 here for copper. We can also put 6. Okay. Now aluminium is how many on the right? 4. 2 times 2, 4. So aluminium here, I put 4 here. We put 4 here in order to balance this. We put 4 here for aluminium. And you can see aluminium is 4 here. Oxygen is this 2 times 3, which is 6. Oxygen is 6. And then you make oxygen 6 here by putting 6 here. If you put 6 here, oxygen is 6. Copper is also 6. 6 copper is now 6. You come and put 6 here for copper on the right. And then aluminium is 2 times 2, 4. And you put 4 here. So this is how to balance. This is what they've done. Okay. This is how to balance. And you can also balance this way. Okay. The balance symbol equation is okay. Okay. So let's move on. We can also balance by putting 3 here. Okay, if I put 3 here, it means I will not put anything here. It means I will not put anything here. Because what we balance is just a division by 2. Like this is the simplest ratio. It doesn't mean this one is not right. This is a simplest ratio. If you divide here by 2, you get this 2. You divide here by 2, you get this 3. If you divide here by 2, you get 1. That's the 1 here. If you divide here by 2, this 6 by 2, you get this 3. Okay, so you can also balance it like this by not putting anything here. By not putting anything here. So if we don't put anything here, so aluminium will be 2. So I put 2 here if aluminium is 2. And oxygen is what? 3. Oxygen is 3. So I put 3 here. copper will now be 3 also. So then I put 3 here. Also another way to balance it. Is that okay? So we move on with balancing of equation. Now deduces symbol equation. Okay, to deduce symbol, I think I have explained this. We've talked about the crossover. For example, aluminium reacts with chlorine becomes aluminium chloride, and I said we end with IDE. Okay, metal plus any halogen. You know the halogen family, group 7 in the periodic table, like fluorine, chlorine, bromine, iodine. I talk about these 4 only. Now these first 4 in the group 7, they are called the halogen. They are the group 7. Okay, chlorine, bromine. So when they react with metal, they become that metal chloride or bromide or fluoride or iodide. They don't become aluminium iodide, become aluminium iodide. If you react with chlorine, become aluminium chloride. Okay, it becomes aluminium chloride. If you react with chlorine, it becomes aluminium chloride. So aluminium solid react with chlorine, a gas. They are gases. Okay, the halogens react with gas, becomes aluminium chloride. Is that okay? Becomes aluminium chloride. Now, what becomes of the equation depends on you. Aluminium, quickly, if you don't know how to write the formula, the aluminium chloride, you write the aluminium down, you write chlorine down. Now you write each of their ions. Aluminium is plus 3. Okay, chlorine is minus 1. So you do the crossover method. You cross this with this, and you cross this 3 with this one. So this one, we don't use the sign, you just use the number. 1 times aluminium, you get Al, you just get Al1, but we no need to write the 1. Okay, no need to write 1. 1x in mass, you don't write 1x, you just write x. No need to write 1. So chlorine times 3, you get chlorine with 3 atoms. You write chlorine like this, you write the 3 here. So this is how I've repeatedly explained this in most of our chemistry class. So I expect every student should know how to write the product's name, is the symbol of the product, okay, in any chemical reaction. So after that, you balance the equation. How then do we balance the equation? You can see here there are 3 atoms of chlorine, but here there are what? Here there are 2. There's 2 atoms of chlorine. So what I can do, since here is 3, what if I put 2 here? If we put 2 here, chlorine will now be 6. So I can put 3 here to make chlorine here 6. 3 times 2. This 3 times 2 will be 6. Chlorine is this 2 times 3, 6, and aluminium is 2. So I come and put 2 here. I put 2 here, aluminium will be balanced, chlorine will be balanced, and the product aluminium chloride will be balanced. Okay, so this is the game. This is how we balance the chemical equation. Now we go to balancing ionic equation. Ionic equation is just to be able to write the ion. Okay, we dissociate the in aqueous solution, ionic compound, dissociate it to what we call the ion. If you take any ionic compound, you put it in water, it will dissociate, you break it to its constituent ions. For example, hydrochloric acid, aqueous, if you dissolve it in water, you form hydrogen ion and chloride ion. Potassium hydroxide, you dissolve it, you form potassium ion and OH negative ion. Is that okay? So this is what we need to know about this aspect. Now let's move on quickly. H2SO4 for example, if you dissolve it in water, you get hydrogen ion and SO4 2 minus ion. You get hydrogen plus ion, and then you get SO4 2 minus ion, SO4 2 minus ion. Okay, this is what you get if you dissolve this one in water in aqueous solution. Okay, so that's that. Let's take a look at more of this one. You see, you have potassium iodide react with chlorine. because chlorine is higher than iodine, it will display iodine. It will now be potassium chloride, and the iodine will be alone on its own. Is that okay? So this is a full balance equation. Take a look at it. We balance the equation after writing. Okay. Replace the ionic compound in the balance equation with the component ion. So we replace each one with the ion if you want to write ionic equation. Potassium is of course is a metal, so it has 1 plus because it has 1 electron in the atmosphere. The iodine is a minus because it's looking all halogen, they are 1 minus. They're looking for 1 electron in the atmosphere. Then plus chlorine. We've done this one, we break this one down. Plus chlorine aqueous, they give rise to potassium, give rise to 2 molecules of potassium ion plus 2 chlorine ion, because there's 2 here, 2 chlorine ion minus, and then iodine plus iodine aqueous. Okay, so this ionic equation. So if you cancel what is on the right and what is on the left, for example, if this cancels this one for ionic equation, and this iodine cancels this, no, iodine do not cancel. Which other one can cancel? Chlorine. Yes, chlorine. Then we get this one. This one do not cancel. Okay, let's remove. So this one is left, 2 iodine plus chloride. You get these 2 chloride plus iodine aqueous. Okay, that's that for that. Let's move on quickly. Key for chemical symbols in periodic table. Okay, this one is very important. We need to know about the periodic table, and we need to know about, okay. Here, I think before we start this one, we need to take a look at our tutorial before we start relative masses, relative atomic mass, which is very important aspect of this chapter. So let's take a look at this second part. Here we want to look at our AR and MR, relative atomic mass and relative molecular mass. Okay, thank you.
In this video, we will be looking at relative atomic mass and relative molecular or formula mass. Relative atomic mass, or AR, is found on the periodic table. Work backwards when defining relative atomic mass. Mass. This is the average mass. Atomic actually means of the isotopes of an element. Relative, compared to 1/12 of the mass of a carbon-12 atom. Relative molecular mass and relative formula mass are both written as MR, but there is a subtle difference. Relative molecular mass is the total mass of a molecule. Relative formula mass is the total mass of an ionic compound. The questions that you are usually asked about relative atomic mass are different to those about relative molecular or formula mass. The way to calculate relative molecular or formula mass is to add up all of the relative atomic masses of the elements in the chemical. We will use 3 compounds to show the process. Step 1 is to determine the number of each atom in the compound. CHO contains 1 carbon, 1 hydrogen and 1 oxygen. CuCl2 contains 1 copper and 2 chlorine atoms, because the small 2 belongs to the element before. BeNO3 twice contains 1 beryllium, 2 nitrogens, because the small 2 belongs to everything inside the bracket, and 6 oxygens. 3 oxygens inside the bracket, which is then doubled because of the small 2 after the bracket. We then look up the relative atomic masses on the periodic table and apply them. So, CHO is 12 plus 1 plus 16. CuCl2 is 63.5 plus 2 times 35.5. BeNO3 twice is 9 plus 2 times 14 plus 6 times 16. Once you have the calculation, you can work out the MR. CHO is 29. CuCl2 is 134.5. BeNO3 twice is 133. Take your time with compounds that contain small numbers and brackets. NiSO4 contains 1 nickel atom, 1 sulfur atom, and 4 oxygen atoms. Remember, the small number belongs to the element before. This means that the answer, as shown, contains 1 nickel atom. It also contains 1 sulfur atom and 4 oxygen atoms. From the periodic table, nickel has a relative atomic mass of 59, as shown in the answer. Sulfur has a relative atomic mass of 32, and oxygen has a relative atomic mass of 16. These values can now be filled into the table. In the question, nickel is given as an example, 1 times 59. So, sulfur contributes a total mass of 1 times 32, or 32. And oxygen contributes a total mass of 4 times 16, or 64. The total mass of NiSO4 is therefore 59 plus 32 plus 4 times 16, which equals 155 for 2 marks. If you did not get a final answer of 155, you can still gain 1 mark for either the sulfur row being correct or the oxygen row being correct. In the second question, XCl2 contains 1 atom of X and 2 atoms of chlorine. Again, remember that the little number 2 belongs to the element before it. From the periodic table, chlorine atoms have a mass of 35.5. So X is 95 minus 2 times 35.5, which gives an answer of 24. The element with a mass of 24 on the periodic table is magnesium. This answer gains 1 mark. Be careful, because a very common mistake in these questions is to use the atomic number on the periodic table instead of the mass number. You should be able to define relative atomic mass as the average mass of the isotopes of an element compared to 1/12 of the mass of an atom of carbon-12. Relative formula mass is the total mass of a molecule. If you are dealing with an ionic compound specifically, then it should be called relative formula mass. To calculate relative molecular mass, you add up the relative atomic masses of all the atoms in the molecule or ionic compound. Take care when the chemical formula contains subscript numbers and brackets. Don't forget to check out all our other fantastic revision results.
Okay, thank you. That's the tutorial. So everything we need to say is being explained by our partners. So let's take a look at, first of all, we're going to learn what is relative atomic mass. And we say relative atomic mass is the average masses of all the elements of isotope, as compared to 1/12 of carbon-12. Okay, so carbon-12 is a benchmark. This carbon-12 is a benchmark when we study relative atomic masses. Carbon-12 is a benchmark when we study relative atomic masses. So we always compare with carbon-12 isotope. So the masses of the average masses of the isotope that we are discussing, of the element of the isotope we are discussing, when benchmark, when compared with carbon-12. That's the definition. In the exam, they always ask you to define relative atomic mass, so you should know it, how to stay. And the relative formula mass is same as relative molecular mass. It's just that you use the word formula when you are talking about the ions of the compound. But if you are not describing the ions, you call it relative molecular mass. But when you are describing the compound in terms of ions, you say relative formula mass. Is that okay? Okay, so when they ask you to define relative formula mass, is the total masses of all the ions in a compound of a molecule. Is that okay? So that's it. So we quickly go to the business of today. We already explained what is relative formula mass, and now we also said we've explained what is relative atomic mass, right, as the total mass of atoms in a molecule, the total masses of a molecule. So that's it. And we represent relative molecular mass or formula mass as Mr. We represent it as Mr. So when you see Mr, we are talking about, when you see like this symbol like Mr, Mr. we use this for Mr. this, Mr. that. Mr is the relative molecular mass. It's the total mass of all the elements in a compound. So, for example, this water is a compound. If I find the total mass of all the elements in this, all the atoms in a compound or in an element, it becomes the relative formula mass or relative molecular mass. Even for elements, the atoms, some element has more than one atom. So if you have more than one atom, if you find the total masses of everything here, hydrogen is 1. So but if you want to find the total mass, you must multiply by 2. So you say 2 times the mass of hydrogen gives you 2. So that becomes the MR of this. But the relative atomic mass of hydrogen is just 1. Is that okay? So the difference between atomic mass and relative atomic mass and relative molecular mass is that relative molecular mass is the mass of the total atoms, or mass of the total mass of the molecule. That's what we call relative molecular mass, the total mass of the molecule. While relative atomic mass is defined as the average mass, average mass of element of an isotope, or isotope of an element when compared to carbon 12, 1 over 12 carbon of carbon. Is that okay? So that's that. Now let's take a look at this, how to calculate relative molecular mass. This is a big deal. So for this we say hydrogen, we must know the relative atomic mass. Remember, atomic mass is AR. Relative atomic is AR. Molecular is MR. So the relative atomic mass is what you find, the mass you find in periodic table. They are their relative atomic mass. The mass you obtain from the period when you open the period. I'm not talking about the atomic number. I'm talking about the mass number, the big number. There are 2 numbers for every element in the periodic table. The big number is the mass. The small one is the atomic number. That big number is the relative atomic number for every element you see in the periodic table. So that number multiplied by the number of atoms, you get the molecular mass. Is that okay? So for hydrogen, you say 2 times 1, because if you check periodic table, the mass of hydrogen is 1. The relative atomic mass of hydrogen is 1. So 1 multiplied by 2, you get 2. So the MR is 2. Now we go to water. Water, hydrogen is 1. You say, so you go to say 1, 2. There are 2 atoms of hydrogen. So you say 2 times H plus, there is 1 atom of oxygen. You say 1 times O. So put simply, H is 1, relative atomic mass of hydrogen is 1. So you say 2 times 1 plus you say 1 times 16. Relative atomic mass of oxygen is 16. 1 times 16. So it gives us a total of 18. So the relative atomic mass of water, relative molecular mass of water is 18. The MR is 18. So when you are doing this, you are doing MR. You can also call molecular mass. Okay, when we are doing mole, chapter 6, the next chapter we are doing. Okay, so let's take a look at this. This potassium carbonate. Why Nate? There's oxygen in it. Okay, I say when you have 3 elements and it ends with oxygen, you go to carbonate. It will end with ATE. It will end with what? ATE. Okay, carbonate. Because of the oxygen, we don't call it oxygenate. We call it carbonate. It just, instead of oxygen, you put 8. Okay, so this is potassium carbonate. Now potassium, you will say 2 times potassium. The mass of potassium is 39. So 2 times 39 plus the mass of carbon. Carbon atomic number is, and number of atoms is 1. You say 1 times carbon, meaning 1 times 12. The relative atomic mass of carbon is 12. So you say 1 times 12 plus, there are 3 atoms here of oxygen. So you say 3, then the relative atomic mass of oxygen in the periodic table is 16. So you say 3 times 16. So we add everything together, 2 times 39 plus 1 times 12 plus 3 times 16, and then we get a total of relative molecular mass of 138. Is that okay? Now, what for calcium hydroxide? Calcium hydroxide, you must know how to write the chemical formula first. Why is this one? This because calcium has 2 ions, 2 positive ions, and OH has 1 minus ion. When you cross multiply, this one comes here, the 2 comes here, and you have to put the bracket because the 2 is talking to oxygen and hydrogen. That's why we put the bracket. Okay, so that's how this formula is like this. Now you say calcium is atomic number, relative atomic mass is 40. So because it has one atom here, you say 1 times 40 plus oxygen, there is 2 because of these 2 outside. 2 times 16. So you say 2 times 16, and hydrogen is 2 times 1 because of these 2 outside. Hydrogen is 2 times 1. So you add everything together. 1 times 40 is 40, 2 times 60 is 32, 2 times 1 is 2. This and this is 34. 34 plus 40, you get 74. You get 74. Now, ammonium nitrate. How is ammonium nitrate like this? Ammonium is +1. The ion is +1. Sulfate, so I say ammonium nitrate, sorry, ammonium sulfate. Sulfate is -2. So when you cross multiply, when you do the crossover method, the 2 up here will come here, become ammonium nitrate. The formula will be written like this. Now, once you know how to write the formula, then you can calculate the relative molecular mass. 2 times nitrogen. Why are we multiplying by 2? Because of these 2 outside. Because here, this 2 is talking to everything inside the bracket. So you say 2 times nitrogen, we have 2, N2. So you say 2 times 14 for nitrogen. Then this one, hydrogen is 8 now. 2 times 4 is 8. So you say 8 times 1. Here you say 8 times 1. Why do we say 8? Because this 2 multiplied by this 4. This 2 multiplied by this 4. This is a very critical topic. These two multiplied by this 4, you get 8. These 2 multiplied by this 4, you get 8. So 8 times 1, hydrogen is 1. That's how we got 8 here. 8 times 1, you get 8. Then for sulfur is 32, and there's only 1 atom. We say 1 times 32, we get this one. And then for oxygen has 4 atoms. 4 times 16, we get this one. So we add everything together, we get 132 for the relative molecular mass. Is that okay? So this is how we do relative molecular mass. We can do for this sodium chloride, calculate the relative formula mass. Okay, it's same thing whether they say formula mass or molecular mass, same thing. Copper 2 oxide, magnesium nitrate. Okay, same thing. Sodium chloride, sodium is 1, so the atomic number is 20, the relative atomic mass is 23. Chlorine is 35.5. So you add them together, and there's only 1 atom of chlorine. So you're not going to multiply. You just say 23 plus 35.5, you get 58.5. Copper 2 oxide or copper oxide, for copper oxide, copper is 63.5 times 1. So no need to say times 1, because it will be the same thing. Plus oxygen is 60, you just add 60, you get 79.5. Magnesium nitrate. Magnesium nitrate, you must know how to write the formula correctly. If you don't get this formula, you cannot get this one. Magnesium, because nitrate has -1. So when 1 come here, so magnesium remains as Mg only. Then magnesium has 2 plus. When 2 come here, NO3 will be bracketed with 2 when it's cross multiply, when you do the crossover. Okay? So now we do. Magnesium is 24, so we just write 24 plus. Now for this inside the bracket, this 2 outside is to multiply this nitrogen. So we now have N2. So whatever nitrogen is, we multiply it by 2. So nitrogen 40 times 1 times 2. This because of these 2, just say 40 times 2. And then for oxygen is 60. 60 times 3 times 2, or you just say 60 times 6. So everything add together, we get 146 for this. Okay? So this is how this is obtained. Now we go to reactive masses. The law of conservation of mass says that the total masses of reactor must be equal to the total masses of the product. The law of conservation says the total mass of reactor must be equal to the total mass of the product. That's why we balance equation. So if you look at this, if it's a balanced equation, before the balancing, these 2 will not be there, and these 2 will not be there. It will just be calcium react with oxygen. Why it will just be CaO? Why is it just CaO? Because calcium has 2 ions, oxygen has 2 minus, this one has 2 plus. When they cross multiply, this one, the 2 and 2 will cancel each other out, so you just have CaO. Okay, now this balancing puts the 2. In order to balance the 2 atoms of oxygen on the left, you put 2 at the back here, so oxygen is 2. Calcium is now having 2, therefore you must put 2 at the back of calcium here. So this is a balanced equation. Now once you have it, once you have this, the next thing to have is to look at their masses. For calcium, since you have 2 here, 2 times 40, you get 80, right, for calcium. For oxygen, 2 times 60, you get 32. So 80 and 32 is 112, right? 80 and 32 is 112 total mass of the reactant. You know, the law of conservation says the total mass of reactant must be equal to total mass of product. So you see here, 40 plus 16 multiplied by 2, you also get 112. So that's the law of conservation of masses. No mass is lost. The total mass of the reactant is equal to the total mass of the product. No mass will be lost. That's the law of conservation of masses. So here, but for that law to work, you must have a balanced equation. You must have what? A balanced equation. Now calculate the mass of carbon dioxide produced when 32 grams of methane, 22 grams of methane react completely in excess oxygen. So we write the equation first. Methane bonds in air, that's plus oxygen, gives us carbon dioxide and water. You must balance the equation. If we don't balance the equation, we cannot do the calculation, right? So after we balance the equation, we find the total mass of methane. 4 times 1 is 4 plus 12, 16. So here we have 16 for methane. Oxygen is 16 times 2 times 2. That would be 60 times 2, that's 32 times 2, that's 64, right? Oxygen will be 2 times 16, we get 32 first. Mass of oxygen, that's the oxygen molecule, we get 16. And then you look at the product side. Carbon dioxide, you have carbon is 12 plus oxygen is 60 times 2. Then you get 44 for this one. And water is 18, right? But 18 times 2, you get 36. Water is 18 because of the 2 at the back, multiplied by 2, you get 36. So we write them out now. The mass of methane total is 16. The mass of oxygen here is 64. Why is it 64? 60 times 2, then times 2. 60 times 2, you get 32. 32 times 2, you get 64. Okay, carbon dioxide is 44. If you multiply 60 times 2, you get 32. 32 plus 12, you get 44. Water, because of these two molecules, water is 18 normally. Because of this, you multiply by 18 by 2, you get 36. Now, the total mass, the question says, so 60 gram, you can see 60 gram of methane react in excess of oxygen of 44 gram of carbon dioxide. Carbon dioxide is 44. The question says how many gram of oxygen? The question says calculate the mass of carbon dioxide produced when 32 gram of methane. Okay, when 32 gram of methane react with completely in excess oxygen. Now in this one, after we do the masses, 60 gram produce 44 carbon dioxide. 32 gram will now produce how many? 88. You know this, the question says 32 gram of this one. The question said 32. Remember, right? The question said 32 gram of this one. The question said 32 for this one. What will be the mass of, if 32 gram of methane react completely in oxygen or bond in oxygen, what will be the mass of carbon dioxide produced? We don't know this one. Okay, we don't know this one. But we are telling you how to do it. Do the molecular mass of this, of this, of this, of this. Now you know that 16 produces 44. When 60 gram of methane reacted, it produces 44 gram of carbon dioxide. Now if it's not 32, what will this one be? Meaning you multiply by 2, right? To get 32, because the question says 32 reacted. So when we did the molecular mass for each one, it was 60 for this one and 44 for this. So when it's 32, it means that it is multiplied, 60 was multiplied by 2. That's how we got 32. So if it's not 32 gram, what will be the mass of carbon dioxide? Meaning we should multiply this 44 by 2. We should multiply it with 2. If you multiply 44 by 2, you get 88. If you multiply this one by 2, you get what? 88. So it means 88 grams of carbon dioxide will be produced when 32 grams of this one reacts. If 32 grams of methane react, 88 grams of this one will be produced. 88 will be produced. Is that okay? So this is how we got this 88 here. This is how we got this 88. 88 grams will be produced. Because when we did the equation, 60 was producing 44. So therefore, 32 will produce what? 88. Because you double this, you multiply this by 2, you must also multiply here by 2. Okay, I think that's all we have for today. Our next class will be Mode, Chapter 6. Thank you for joining us.